This video, we are dealing with section 8-4, which we are talking about the angle of elevation and the angle of depression. Now, up here you can see where I have the little stick person here. When you are down on the ground looking up at the plane here, this with the horizontal, where the person looking straight out is the horizontal, and then the angle of this line of sight, person looking up at the plane, that forms an angle of elevation. And then if you were up here in the plane and then looking down at the person on the ground, you have your horizontal where you look straight out from the plane, and then the line of sight down to the person on the ground from the plane. That forms the angle of depression. So angle of elevation, you're on the ground looking up, and angle depression, you're up in the air looking down. Now, you could be on the top of a building looking up and see a plane and have an angle of elevation, or you could be in a hot air balloon, you're looking up and you see a bird. You could form then your horizontal and your line of sight form an angle of elevation. Same thing if you were up above in the balloon looking down, then you have your horizontal line of sight, and then your horizontal straight out, and then your line of sight down would be your angle of depression. As you can see, since these horizontals would be parallel, then these two angles here would be alternate interior. And when parallel lines, alternate interior angles are going to be congruent. So your angle of depression and your angle of elevation would be the same. They would be equal. All right, so your first type of problems you're going to be dealing with, you will be trying to pick out which angles are angle of elevation, which ones are angle of depression. Just always remember, angle of elevation, you're down looking up, your horizontal and looking up forms your angle of elevation. And if you're up in the air, the horizontal and looking down forms your angle of depression. And remember, they will be congruent, they will be the same. Now, we also have now an example here in a story problem. An air traffic controller at an airport sights a plane at an angle of elevation of 41 degrees. The pilot reports that the plane's altitude is 4,000 feet. What is the horizontal distance between the plane and the airport? Round to the nearest foot. So we have this particular problem. And we're going to, first of all, we need to draw a diagram to illustrate what is happening in this situation. All right, so the first thing I'm going to do is I'm going to draw a diagram. And so I'm going to make a triangle. And so I would draw my triangle here, where this will show that up here I have the plane. Down here is the airport, and then the altitude would be from the plane down to the ground, and he said that was going to be 4,000 feet. And he wants to know then, in this particular problem, how far it is for the horizontal distance. They're trying to find how far it is from the airport down here to where it's on the ground, which would be your X, and that is what we're trying to find. And so that would be my diagram that I'm dealing with. Now, again, we go back to last section 8.3. We're going to be dealing with sine, cosine, and tangent. And so we're going to have to set up a problem using our ratios to find out this missing side. Now, this would be a right angle. This would be straight down, and so we do have a right triangle. And now we've got to figure out what we're going to use, sine, cosine, or tangent. Now, the hypotenuse, which is over here, we are not using. And so that means it would have to be tangent. The tangent of our angle, which I forgot to put in the angle, which is 41 degrees. That is my angle of elevation. It told us that in the problem. So angle of elevation, always remember, would be down here at the airport looking up at the plane, and here's the ground level, and so that would be your angle of elevation. And so tangent of 41 degrees equals opposite over adjacent. So it would be 4,000 over x. And so that would be your setup. So we've got tangent of 41 degrees equals 4,000 over x. So now we're going to set up our proportion. Then I would just put this, I can just put this over 1 to make it into a proportion. So I've got tangent of 41 degrees over 1 equals 4,000 over x. And then I'm going to cross multiply and solve. X times tangent of 41 degrees equals 4,000. 1 times 4,000, we're cross multiplying. Now to get the x by itself, I've got to divide by the tangent of 41 degrees. And so then I divide both sides by the tangent of 41 degrees. And so those are going to drop out. They're going to be eliminated, and I get x equals, and now then you would have to use your calculator again, and we're going to punch in 4,000, and then we would hit the divide symbol, and then we need to hit our tangent button, and then 41 degrees. And then we would hit enter or equal, and we end up with 4,601.47, and it said round to the nearest whole number, and so it would be 4,601, and that would be feet. And so the distance from the airport to where on the horizontal on the ground to where the plane on the ground is right above that x, that value would end up to be 4,601 feet. And so those are type of problems you're going to have in this section. You're going to have like story problems. They may give you a diagram, or you may have to draw out a diagram from the paragraph that they give you, and you may have to draw it out, and then we go back to last section, and you already know how to do this. And so you just have to figure out whether it's going to be sine, cosine, or tangent, and then solve for your missing side of your right triangle. And so, again, if they give you a diagram, that's good. If they don't, then you need to draw out a diagram and then come up with your setup using your sine, cosine, or tangent.